The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, great. So a lot of effort went into making this course, and we hope that you've had fun. There's been a lot of support from Sony, IBM, Toshiba, a lot of on-demand help from people at IBM and Sony trying to debug problems even up to the last minute. So we're very thankful for that, and we hope in return that you really enjoyed the course and it was really fun. So looking forward to the course evaluations. So just want to tell you a little bit about some opportunities ahead. I've passed out these brochures for the Cell Broadband Engine Challenge Beyond Gaming. And this is an IBM-sponsored event where you really can compete in two different challenges. And in one of them, you can win really seriously cool t-shirts. That's actually lifted directly from the online link. So the competition starts February 5 at midnight. And you have to pass an online quiz, of which I expect all of you should be able to pass. And hopefully you will compete and at least get a seriously cool t-shirt. The second challenge, which is potentially more interesting, just because there's a 10K grand prize. There's also a 7K second prize and some serious money for at least 3 or 4 prizes. You can look at the information in the brochures. According to the information you'll find, it requires some serious coding skills on your part. But I certainly expect all of you to be able to be well primed at this point, especially since you've learned about Cell hands-on, you've sort of discovered all the pitfalls on your own. It would make for a very good competition on your part. There are different categories. Sorry, it's 3 categories, not 4. Application solutions. So some of the people who have done more application-oriented thing could fit, or you can sort of took what you've learned, apply it to financial services if you have interest in that, medical imaging, electronic design, automation, things of that sort. Operating systems, I'm not sure if that's particularly relevant to a lot of people here. I'm not sure if that's in their interest area, but programmability, so certainly the streaming framework that one of the software radio projects tried to do would fit onto that. Some of the work that the ray tracing team did in terms of coming up with their own interface for graphics could certainly fit. So I urge you to sort of consider competing in these. There's probably a lot of fame and fortune to be had here. So we had our own competition, and what you're going to get are some seriously cool trophies, since we don't have t-shirts. So Mary was very could have had t-shirts. I didn't want to compete with IBM directly. So for the winning team, you will get this seriously awesomely looking trophy, which has a little imprint on the front that says first place 6.189. And you're also going to get a $150 gift certificates. I think we announced this at the beginning of the course. I'm also working with people at IBM on arranging a one-day trip to IBM TJ Watson Research Center for the winning team to sort of present their winning project, do a demo, and then meet with people at IBM who are sort of doing really cool, interesting research. And it should be a fun day. And certainly people at IBM have been very excited about hearing what's going on in this project, in this class. And so it'll be a good, fun opportunity, I think, all around. Okay, so I'm going to work my way up to the first prize. I think in terms of the complexity of the project handled, certainly speech synthesis tune probably took on the most complex, certainly in terms of the software that they used. And maybe that bogged them down a little. So there's probably something to be said in terms of starting from scratch versus taking complex infrastructure and re-engineering it for parallelism. I think you've discovered firsthand, how hard that really is. And this is, a big problem for parallel computing. There's a lot of legacy software out there that eventually might have to be ported to parallel architectures. How do you do it? You pointed out code is not well documented. Tools are lacking. So what do you do? So you've stumbled on a really seriously important problem facing a lot of people in the industry. The most synchronization issues, we believe the guys who are doing the battery simulations and modeling sort of chemical reactions certainly ran into a lot of synchronization issues just because of the dependent nature of the computation. The next up on the list would be for the most parallel programming challenges. So not only did they run into issues with synchronization, but certainly discovered problems with races, and I think they're the only team who have successfully hung their PlayStation 3 several times and required a reboot quite a few times. Okay, so next, Best Effort Awards. These guys should really be highlighted because they worked largely on their own. Is that true? Yes. Yeah, and that's certainly true. And there was certainly a lot of people who were impressed by the global illumination stuff yesterday and sort of mentioned that. And what I'm hoping to do is take the judges' feedback and sort of summarize that for each team so you can have some constructive criticism back that might be helpful. Molecular dynamics simulation work that you heard about today, I think certainly a valiant effort on his part as well. The most complete project, I think this was probably the Backgammon Tutors project. I think in terms of scope, it was well defined. In terms of what they actually completed, I think they came out with a really cool game. My money was on them all along to actually win the first prize, but I think the ray tracing team actually blew everybody away with their demo. And I think they were a clear winner. They had they tackled sort of the parallelization, the sim dicing. They had a really cool frame buffer demo, so they figured out how to actually write to the frame buffer and do that simulation or do the graphics rendering. And I think some mumbling about a really cool demo that they've gotten working overnight. So we'll try to set that up over in Stata where we have pizza, and you guys can take a look at that. So with that, I'll hand out the certificates and the awards offline. But you've, at this point, been cellified. And the cake is in the back, says, congratulations on your cellification. So that's right. So thanks a lot for taking the course. I think we've learned a lot as instructors. I'm hoping to do this again with Saman next year, next IAP, and maybe eventually turn into a regular semester course. I think there's a lot of things we can do better. And hopefully you've told us some ideas of how to do that. So with that, thanks, and let's start enjoying cake in the back.